We'll take some time in this video to review the process of multiplying fractions. Now, the added layer of complexity with these problems is that we are now bringing signs into the mix. So we just want to remember, regardless of what type of numbers we're talking about, if we're multiplying or dividing, we need to count the negative signs. And if you have an even amount of negatives, you will get a positive result. And if you have an odd amount of negatives multiplied or divided, you will get a negative result. So that will always stay intact regardless of the type of numbers that we're talking about. From there, we just want to follow this process. So there'll be the process of if we have mixed numbers like we have in the second problem to convert those to improper fractions. We'll want to make use of cross-canceling. Now, cross-canceling is just making use of greatest common factors on the diagonals, as we'll say, to try to reduce the numbers down. And then we'll be ready to multiply our numerators, our top numbers of our fractions across, and our denominators, our bottom numbers in our fractions, we can also multiply across. And then we'll simplify by making the answer, if it's an improper fraction, back into a mixed number and reduce as we need it. So all that being said, let's get started on probably two of these examples. So I take a look quickly at my signs. I see that I have a single negative sign. So I know my answer will be negative. So I'm just going to make a note of that so I don't forget about it. I don't have any mixed numbers to convert, so I can just move on to my cross canceling. So that means I'm going to look at these diagonals. I'm going to look at the 9 and the 3 and see if they share a common factor. I'm going to look at the 4 and the 16 and see if they share a common factor. So we'll start with the 9 and the 3. We should recognize that 3 and 9 share a common factor of 3, and therefore we can reduce each value accordingly. So 3 divided by the common factor of 3 is 1. 9 divided by the common factor of 3 is 3. We'll also take a look on the other diagonal. We can see that 4 and 16 share a common factor of 4. So 4 goes into 4, or 4 can be reduced by 4 one whole time. And 16 can be reduced by 4 whole times. So our new problem is now essentially negative 1/3 times 1/4. So this is a lot easier for us to focus on or to do the math on, because the numbers are so much smaller. And now all that we're left with is multiplying our numerators across. 1 times 1 is 1. Our denominators across, 3 times 4 is 12. And then just don't forget, we made note that the answer would be negative by counting the signs. So our answer is negative 1/12. We'll take this through one more time because this has mixed numbers. That has the added layer of complexity of having to remember to convert those mixed numbers to improper fractions. So one more time, we will start by counting up the negative signs. I have 1, I have 2. I know my answer is positive. Here, however, I'm going to have to convert these numbers from mixed numbers to improper fractions. So ignoring the signs, we take the denominator times the whole number. We know 3 times 3 is 9. And then we add the 1. So I know I will get 10/3 there. And notice I'm ignoring the signs at this point. I already have my sign in my that I need to carry through to my answer taken care of. So I'm not going to worry about the signs as I do the work. So one more time, I'm going to do 4 times the whole number 2 is 8, plus 1 is 9. So I have 10/3 times 9/4. I can now move on to cross-canceling. I can see that the 3 and the 9, that should look awfully familiar to me, reduced by a factor of 3. 3 reduces to 1. The 9 reduces to 3. Now, this is easy for us to get caught up on and believe that there is no cross-canceling here. But we're looking for any common factor that goes into both 10 and 4. And in this case, 2 goes in. So 4 divided by that common factor of 2 is 2. 10 divided by that common factor of 2 is 5. So where we stand now is we just simply have a new problem that is basically 5/1 times 3/2. So we can multiply 5 times 3 equals 15 over 2 times 1 is 2. And then the last thing we'll need to do, so here's where we are. We went all the way through. We checked our signs. We converted improper mixed numbers to improper fractions. We cross-canceled. We multiplied numerators and denominators across. And the last thing we're going to do is to bring this back to a mixed number. Now that's done by simply seeing how many times 2 goes into 15, how many whole number times. We know that's 7 whole times. We know 7 times 2 is 14, which means that there is 1 left over to get us to the 15. So 7 and 1/2. I take one last look. That's right. I knew my sign was positive, so I don't need to worry about dropping a sign. And our final answer is 7 and 1/2. So what I would like you to do is to refer back to these two problems and finish up the remaining problems that you see. And then we will continue our discussion in class.